Hello folks, I'm going to show you the conservation of mass lab. So a little bit of background, the law of conservation of mass, also known as the law of conservation of matter, states that matter cannot be created or destroyed, but it can be changed in form. So in other words, when a chemical change occurs, no atoms are lost or turned into other atoms, the atoms are only rearranged. Since the total number of atoms and masses of the atoms never change, the total mass is also conserved. This is called the law of conservation of mass. So in this lab, we're going to model a chemical change and determine what happens to atoms during a chemical reaction. In this lab, the various coins represent a different atom, and we're using 17 coins in total. So the procedure is to sort the coins into stacks of pennies, nickels, dimes, and quarters. And this is going to be for trial 1. Then we're going to calculate the value, the number of cents in each of the 4 stacks and record it in our trial 1 below here. All right. And then we're going to total up the number of each coin. So here we go. So I have my container, pour them out, and divide them up into the different stacks. Each coin. Okay, so I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pennies, 2 nickels, 3 dimes, and 2 quarters. So let's record that on our sheet. So we have stack 1. How many cents? 10 cents. 10 cents. Stack 2. We have, these are both worth 5, so we have another 10 cents. And dimes are each worth 10 cents, so 10, 20, 30. And stack 4, we have 2 quarters, both worth 25, so that is 50. 50 cents. All right, so 50 plus 30 is 80. Plus another 10 is 90, plus another 10 is 100. So we have 100 total cents. All right, how many of each coin do we have? Pennies, we have 10 pennies. So write in 10 pennies. Nickels, we have 2 nickels. Dimes, we have 3 dimes. And quarters, we have 2 quarters. All right, that's the first trial. Next, we are going to mix all the coins together and then divide them randomly into 4 unsorted stacks. And then we're going to do this same thing. All right. So you're going to take your coins and you're just going to mix them up. Oops. Mix them all up randomly. We are rearranging the atoms right now. This is a chemical reaction. We're rearranging the matter. All right. And so we got our stacks. So here we go. And all right. So next, you are going to count how many cents are in stack 1 and record it here. How many cents are in stack 2? And you're going to record it on your own for your example there. And then keep doing that. And then record the total number of each. All right. So you're going to repeat the steps. Our next step, after we have completed all 3 trials, is you're going to answer these questions in the model. What do the coins represent? Number 2, the total number of atoms or coins change in any of the chemical reactions, and then explain why. And then number 3, how does your model and data above support the idea of conservation of mass? This model shows that the number of coins or atoms either changes or does not change, so circle 1. Even though the atoms or coins can be rearranged. This is called the law of blank, and it states that blah, 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 blah. So you fill that part in. Then I need you to clean up your coins. Make sure you have 17 total and put them back into your container and close the container. Ba-ba-da-ba. All done.